All right, well, good morning or good afternoon. We're here with period 3. Hi, period 3. Okay, so last time in class, we did the notes on solutions and concentrations. The first part, molarity, that's a previous video. What I'd like you to add on to this is going to be down at the bottom here. So I don't want to give fresh notes here. Let me scoot this over. I'd like you to draw the bottom half of the notes. Did you do about half your notes last time, about half a page? Is that where we ended up? Okay. So let's add an equation triangle for molarity, or if you don't like the triangle, you can do an equation circle. We draw a line across half of these. And for molarity is moles divided by liters. That was our base equation we worked with. And then I'm going to put big capital M over here. Please be careful to always put capital M when you're doing these. Hey, would you shut the door over there, because those birds are kind of noisy. So what's nice with equation triangles is that if you've got to rearrange the equation, if we ask you for molarity, you cover up what you're looking for, and it's moles divided by liters. Or if we're asking you to calculate the volume, you cover up the liters, and it's going to be moles divided by molarity. Or if you need to find the number of moles of material, you cover up moles on the triangle, and you've got molarity times liters. So it works if you, like I said, if you prefer this, moles over liters, and this would be molarity there. So they can kind of help you when you get these problems, depending upon what you're looking for. Oh, and I guess up here, we should put the MVP triangle. Mole, we got M, V, and P, and we have to convert to grams and sometimes grams to moles. So we're going to have another conversion chart kind of hooked by the upper corner of it. So that was what we kind of reviewed last time. So we're working within this one, but occasionally we got to figure out grams, because ultimately if you're mixing up a solution, you got to know how many grams to measure on the scale. So the assignment we're working on, the notes we're doing today, part 2 now. Part 1 was molarity, the moles divided by liters. This concentration is going to be percent concentration. Percent concentration. And let's see, percent concentration is going to equal to, let me zoom in here so you can all see that a little better. It's going to equal the amount of solute. Amount of solute, that's the solid stuff. Oh, I got some leak through. There we go. Turn that around. Amount of solute in the total solution, in the total amount of solution. In the total amount of solution. So percent concentration, how many grams of solute we're going to have in the total amount of solution. And we're going to have a little definition for what total amount of solution is here when we do the equation. So part A, we're going to have 2 of these. We're going to have percent by volume and percent by mass. We'll do percent by mass. And what that's going to equal, I'm going to rewrite it here. Percent M, that's going to be for mass. I'll write mass just so we don't get it, is equal to grams of solute. So grams of solute, I'll just put the unit as grams. And we got to divide that by the amount of solution. Oops, sorry. Amount of solution. See if I can make that N look more like it. There we go. Amount of solution in grams. Now, the amount of solution is going to be the grams of solute plus grams of solvent. So you've got to measure how many grams of the solid stuff and how many grams of water. Usually the solvent's water. Oh yeah, and I forgot to put something up here. This times 100%. Because when you do this, grams of solute divided by how much the whole solution weighs, you'll get a fraction, a decimal, and we'll change it into a percent. So, for example, let's do a practice problem on this, and then we'll get to our lab. Example, let's say we have 25 grams of salt dissolved into 100 grams of water. Percent mass equals. That's what we're looking for. So we go back up here to our, okay, so do you need a moment to write that out? 25 grams of salt dissolved into 100 grams of water. So we use our equation up here. How many grams of solute do we have? Nope, we don't. This is the grams of water is the solvent. So how much solute do we have? I can't hear you.
25.
Thank you. Yeah, I got these older ears. 25 grams. I'm just going to put NaCl. That's our solute. We've got to divide that. Now, we got to do it by the amount of solution. The grams of solute plus the grams of solvent. So we've got 100 grams of solvent. That's the water. So what's 100 plus 25?
125.
That's going to be 125 grams of solution. And then we need to multiply that by 100%. So get your calculators out. And 25 divided by 125. And I know some of you are going, hey, wait a minute. 25 goes in there once, and 25 goes in there 5 times. It's 1/5, but we need the decimal. And then when you get the decimal, you got to multiply it by 100. What did you all get? 20%? So this solution, we would say it's 20% NaCl by mass. So that's how we do problems like that. So we'll call that a day there. Goodbye. Bye, period 3. Thank you.